Welcome, everybody, to today's webinar, GCP Kubernetes Deployments and Provisioning with Octopus. My name is Sean Cessna. I'm a Senior Solutions Architect here at Octopus Deploy. Joining me today from across the pond is Matt Casperson, Product Manager.
Hi, thank you. It's good to be here.
Excellent, excellent. Yeah, I think this is going to be a pretty good webinar. Before we get started, though, let's go ahead and do a little bit of housekeeping. We are recording this webinar, so there's no reason for you to record it. A link to that recording will be available 24 to 48 hours after the webinar is over. If you have any questions, you can use Slack, which is octopus.com/Slack, and the webinar channel to ask those questions, or use the Zoom Q&A. We'll do our best to get to all those questions, and if not, we'll try to get back to you with anything else. So let's take a look at what we're going to be talking about today. So today we're going to provision a GKE cluster using Terraform. And not only that, we're going to be using the Octopus Deploy Terraform provider. So that's going to be really cool. We're going to be deploying the random quotes application, which consists of a front end and a back end. And Matt will go into more details about that. And lastly, we're going to troubleshoot a failed Kubernetes deployment using some runbooks. So this is a good opportunity to see how those can be added. So without further ado, I'm going to hand it over to Matt so you can take a look at why you're really here, which is that demo.
Okay, thank you. All right, so as Sean mentioned, the bulk of the demo here will be deploying an application with a front end and a back end component. But to do that, we'll have to first create a Kubernetes cluster and represent it in Octopus as a target. So I just want to show you quickly what we've pre-provisioned here in our hosted instance. I have created a number of environments, dev, test, and prod. So this represents your fairly typical application deployment progression. I've also got this administration environment here that will represent a lot of cross-cutting DevOps or deployment concerns, things that tend to affect more than one environment. And we do have a root account here. So this is a Google account. It's one of the new features that was released in 2020.1. And the key file here actually represents or is created by the JSON file that you can create against a Google service account. So we'll start off here by running this a runbook that we've got here. And so this runbook has a single step, which is a Terraform step. And this step will create both a cluster within Google Cloud and the associated target in Octopus. So I'll just run through the source code quickly for this. So you can see we're using the Octopus Terraform provider. So this is a provider that is available for download from the HashiCorp website. All we need to do to use the Octopus provider is add it here as one of the required providers. You'll notice that we're not quite at version 1 yet of this provider, so there is still plenty of work going on with that provider. But we do have quite a few large customers using it for fairly complex deployments, and it's proved to be quite a useful tool for that. We're also maintaining state in a Google bucket. So you can see here that we've created this backend block that will create a state file for us back in the Google Cloud. So this is where we configure the Octopus Deploy Octopus provider. As you can see, I've pointed it here to the the host name of our hosted instance, and set up an API key and a space ID. We then have a bunch of variables, the Octopus ID, space ID project, a whole bunch of variables that relate either to Octopus itself or the cluster that we're going to deploy into Google Cloud. I've then used a lot of these data blocks here to query the state of an environment within Octopus. So we do this because when we're referencing a environment as part of our deployment within this Terraform script, we actually need to use the ID of an environment as opposed to the name. But it's actually a lot easier to remember the name of an environment. So by performing this data lookup, we can get access to that ID. This block here is all it takes to create the cluster in Google. We're using a autopilot cluster, which means that Google is going to take care of scaling the nodes in and out for us. And so that's a really nice feature and just removes some management that we would otherwise have to perform ourselves. And then finally, we have the target within Octopus pointing to that cluster. So you can see I've given the target a name, some roles. Here I've placed the target in a number of environments, and this is where I access that ID property of the environments. We then have a default worker pool and a container that we run the health checks in. And then finally, we have a reference to that Google account that I showed you before.
I noticed that for the data blocks you're using for the environment, could you have done the same thing with that worker pool?
So you can't do that today. So if you look at the documentation for the provider, you'll see there are a whole lot of data sources here that you can look up. Worker pools just aren't one of those yet. But as this project is undergoing a fairly heavy amount of development, that is something that's likely to be added in future. So I'll just go ahead and run this runbook. Now we have actually pre-provisioned the Kubernetes cluster previously, so this Terraform script won't actually take that long to run. So I'll just jump quickly here. So this is the cluster that we provisioned with this script previously. And so the Terraform script will actually detect that this resource already exists and simply skip over it. While we're waiting for that to go through, I might just have a look at some of the variables that we set up. You mentioned, Sean, the worker pool. Was that something we could look up? Even though it's not something we can actually look up with a data block, we've actually set it up here as a worker pool variable type. And so this has allowed us to select the worker pool as a variable. And then that's passed in, if we look here, that's just passed in as a variable, as one of the properties that's exposed by that Terraform script. Also do want to call out here that the Terraform step has been updated to use a Google account natively. And so what this means is that Octopus will take care of setting up the environment variables that Terraform expects to have populated to reference the Google account that the script will be deployed against.
It looks like you could use a VM on Google too with a role assigned to it. Is that correct?
Yeah, that's true. So what we've done here is actually used a account directly. What we could have done is had a worker placed on a VM within Google Cloud, and the VMs in Google Cloud can have a service account assigned to them. And if we clicked yes to this option here, what we would do is basically inherit the service account that was assigned to the VM. And so that's a useful feature for lifting a lot of credential management out of Octopus and back into the cloud itself. All right, let's go back to our Runbook. Okay, so we can see that we've leased a dynamic worker, and we're now just pulling down one of the worker images. And so worker images are a convenient way of exposing a lot of common tools like the G-Cloud executable, kubectl, and Terraform itself. And so this is useful, obviously, for the Terraform step because we need the Terraform executable to be exposed for us. And so that's this setting here. And so we're pulling down this worker tools image. This is one provided by Octopus itself. It's a general purpose image. It includes most of the executables that you'll need for cloud deployments across AWS, Google, and Azure, as well as tools like Terraform. Okay. So our worker has pulled down the image, and we now proceed to the deployment of Terraform itself. What we can see here is Terraform going through, downloading the Octopus provider from the HashiCorp website. It will scan for that GKE cluster that already exists, and then we'll go ahead and create the Octopus target, which we can see here. And we're done. So if I go back to my infrastructure page, we will see a Kubernetes target. And so again, one of the new features in 2021.2 is native integrated Google support within the Octopus Kubernetes target itself. And so again, we've just used that root Google account to point to the new cluster that we've created in Google. And this is that same worker image used for health checks against the Ubuntu worker pool. So I'm just going ahead and run a health check just to make sure that everything's good. Actually, it looks like we already have, so that we know all the settings are correct. But what we'll see here is that the health check itself pulls down that same Docker image, which gives us access to kubectl, which is one of the requirements for passing the health check. And there we go. So the health check is passed. So now that we have our root Kubernetes target, the next step is to create application and environment specific deployment targets that will be used to deploy the front end and back end applications. And so we do that because we don't want to have our applications deployed with like administrator access. We want some guarantees that when we deploy our application to a particular environment, that it can only edit that particular environment. And this is especially important in this example because our single cluster is going to host all three environments, dev, test, and prod. And so we need to make sure that wayward or misconfigured deployments don't corrupt or interfere with the resources in another environment. And so to do that, we'll use another Runbook, which I've got created here. And so this uses two steps, both sourced from the community step template. And that's this one here, Kubernetes create service account and target. And so this template will use a account like the root account we created before to create a namespace that represents an environment and an application. We'll then create a service account in that namespace that has access only to that single namespace, and then represent the service account as a token account in Octopus. And so we're going to do that twice, once for the front end and once for the back end. And so the end result of this will be 6 namespaces. So that's front end and back end times the 3 environments. And that will be also then 6 token accounts to grant access to those namespaces. So we'll go ahead and run this. And one of the benefits of using Runbooks is that I can actually deploy to all 3 environments at once because Runbooks aren't tied to the deployment progression or life cycle that regular deployments are. And so the end result of this, once these have completed, we'll see those 6 additional Kubernetes targets in the infrastructure page, and each of them referencing their own unique service account. And those service accounts then are restricted to the namespaces that they are created in. So here we can see the script has started running. We've actually created a target here. It's just running through the health check now. These are the resources that you can see being created on the Kubernetes cluster. So this is the service account here, and these are some roles and role bindings of that service account. So this is the new Kubernetes target in Octopus, and as we can see that the health check is passed for that fine. So that's the one for the front end, and then we do the same for the back end here as well. Okay, So if I go back to my infrastructure page, what we'll see is we now have 7 targets. We have this root target that we created first up, and then 6 targets, one for each of the environments and each of the applications, the front end and back end. And so each of them are backed by their own unique token. Again, 6 additional here, one for each environment and each application type. So we now have all the infrastructure we need to go ahead and deploy our applications. And so to do that, we'll use a standard deployment project, which I have here. If we just look at this quickly, what we'll see is we're using the Deploy Kubernetes containers step. So this is the opinionated form-based step that is used to deploy resources like Kubernetes deployments. And what we can see here is that we're deploying this public Docker image here, random quotes backend go, and we're deploying this as a deployment called random quotes backend. So for those who haven't seen it, this edit YAML button is really quite handy. What it does is give you a reasonable approximation of what's actually going to be deployed to the cluster in YAML format. And this can actually be edited. So there's a two-way edit here. So we'll see that in action later on. But what I'm going to do now is just go ahead and deploy this application to the development environment. Do the same for the front end. Again, it uses the same process here. We use that opinionated step to deploy the container. So I'll go ahead and run that as well. Okay, so if we look at the logs here, we can see that the deployment of the backend has succeeded. And I do just want to show you quickly the verbose logs of this deployment. So I noted earlier that you could look at the that edit YAML button and get an approximation of the resource that was going to be deployed. If you look at the verbose logs of the deployment, you actually get the real YAML that's being deployed to the cluster. So there are some differences. The live deployment has a bunch of labels added, for example, but otherwise the two are very similar. So we can see here that we've deployed the resource, sorry, the deployment resource. So that's this one here, client deployment. And then we've exposed that with a service of type load balancer. And so that's going to give us a public IP address through which we can access this, this particular deployment. The other thing we've done here is scraped or collected the public IP address of that load balancer and exposed it here in the task summary as a kind of a bookmark. I'll actually show you quickly how we do that because it's quite a neat trick. So this second step here is a run a kubectl script step. So this just runs whatever scripts you want in the context of a configured kubectl command line tool. And what we've done, if I just go to full screen, is query the services, grab the IP address of the load balancer, and then used write highlight to print out this markdown syntax here. And so that gives us essentially a bookmark in the, if we look here, essentially gives us this bookmark in the task summary. So I'm just going to go ahead and open this up.
That right highlights one of the solutions team's favorite commandlets.
Yeah, I can see why. I only learned of it recently, so I thought it was worth sharing with everyone else. Yeah, so it appears something's gone wrong. Obviously, I don't expect to sit here and wait for seconds for a quote to come through. And here we go. Actually, the request is timed out. So there is some problem with our deployment. And this is quite by design. We actually did this specifically as part of this presentation because What we really wanted to show here was how to use Runbooks as a way of supporting your Kubernetes deployments. And so I have this project here called Support Runbooks, and in it I have a bunch of runbooks here that have been pre-configured. And so anyone in support, I think, will understand that half the battle of supporting these kind of issues is getting the correct information. And getting the correct information often requires that you have access to the cluster itself. And so that'll be typically mean that someone's shared around the root security credentials, so you can set up kubectl for yourself and start splunking around your cluster. That will work, but at a certain point, it stops becoming feasible sharing root credentials like that and having support personnel have the quite detailed understanding of Kubernetes that they need to diagnose these sort of issues. And so what we've done here is actually created a number of runbooks that automate that process for you. So here we have a runbook with a bunch of steps. And this runbook would be something that is run by support personnel as kind of a first initial check of a cluster. And so these steps are a whole bunch of those run kubectl script steps. And really, they're just running through and verifying the basic configuration of the cluster. So for example, here we have a script that queries that the random quotes deployments actually exist. That's obviously a prerequisite for our software to be running correctly. So we do that for the front end and the back end. We then check that some pods exist. Pods are the things that actually respond to network requests, and so obviously we expect to have a number of pods as well in our cluster. So we do that for the back end and front end. We then check the status of the pods. So it may be that the pods exist and have been deployed, but they're not in a ready state. And if they're not in a ready state, that's a red flag that we need to investigate. And then we go ahead and check the logs of the individual pods. And so in this example, what we've said is one of the standards that our applications adhere to is if they encounter an error, they'll actually place the word error in the logs. And so this is something we can scan for here. So it is worth noting, actually, all these steps are running on a Linux worker, but we are still using PowerShell. And so one of the reasons why I like PowerShell is because working with JSON is just so much easier. JQ is a very powerful tool, but I can never remember the syntax. So if I have to write a script that parses JSON, my go-to is actually PowerShell. And the Ubuntu workers here have PowerShell on them. So we can still do that, and they will run without any problem. So what I'll do is run this initial checks work runbook, and we'll see what kind of results we get.
I'm really glad you said that the error was on purpose, because every time I've done a Kubernetes webinar, it's actually been quite the opposite.
It's a strategic choice. Always introduce an error, and then you can say that was on purpose. So what we'll see here are those runbooks being run in sequence. And something to take away from this is that this is very easy for someone in the support department to run. All they need is access to Octopus, and all they need to be able to do is hit the run button. They don't need a particularly deep understanding of Kubernetes at this point. All that knowledge has been embedded into the scripts that we've provided. And they certainly don't need any credentials on their local machine. So there's no risk of them or anyone really deleting resources or accessing things that perhaps they shouldn't as part of that investigation. Okay, so here we can see the first of our steps is running. It's performed that check to see if the deployment actually exists, and it does. So our step is passed and everything looks good. So we did that for the front end. Now we're looking to see if the pods actually exist. And again, they do, so that's fine. course, check to see if the backend pods exist. And again, they should. Yes, so the front end and backend pods are working as we expect. So here we're going to check the status of the pods. So this is where we check if the deployment of the pods itself had any errors. Quite often you'll find cases perhaps where they can't pull down the image and they return a crash back-off loop. So that's what we're checking for here. So the front-end pods look like they work, but here we see the back-end pods. Some of them aren't ready. And so this is a pretty good indication that there is actually something wrong with our back-end pods. And you'll see the Runbook here actually includes instructions on what the recommended next steps are. And so these next steps would be to click or run the restart backend pods runbook. We've also gone in and inspected the logs of the backend pods, and we've seen an error has been reported by the application itself. And this looks like it might be a fairly serious error. This might be something we need to escalate to level 2 support. But let's run this restart backend pods runbook as our first attempt at remediation. So there's this one here. I'll go ahead and run this, and then we'll look at the steps that are involved in the backend. Sorry, in the runbook itself. So here we can see we've used a 5-step process for attempting to fix the problem that was reported by that first runbook. So the process we run through is this inspect script. This will go and look at the state of the cluster and see if it matches the state that we expect for this runbook to try and fix up, which is really that some of the backend pods are not ready, as was reported by our first runbook there. We then have a confirm step. And so the reason for this is if we ran this script and all backend pods were found to be ready, we just want to prompt the operator to confirm that they still want to go ahead. There may be context that the help desk knows that our inspect script doesn't account for. And this is a way of allowing the help desk or the support personnel to continue even if the state of the cluster is not what we expected in the inspect script. However, if there are backend pods in a not ready state, the confirm step here will just be skipped, and we'll skip straight to the rectify step. And so the rectify step is fairly simple. In Kubernetes, we delete the pod, and then we allow the Kubernetes deployment to recreate it. And so this is important because deleting a pod sounds like it's a very destructive action, and you'd have to have a reasonable understanding of Kubernetes and how it works to understand that in this situation, deleting pods is not destructive. It's actually just essentially a way of restarting a pod. And so by putting this logic into a runbook, we've captured that business knowledge in an executable format instead of relying on every individual support personnel to understand how to run these actions and that these actions are safe to run. We then have a verify script. So this is really a test that that deleting and recreating the pods did solve the problem that we expected to solve. And so in our case, the script here will just go through and check the ready state of all the pods again. And then finally, we have a notify step. And so this sends an email with the results of this runbook. So if I go back and look at the execution of this runbook, what we can see is that the inspect step did actually determine that some pods were not ready. This matches our expectations, so we know we don't actually need to confirm this. We then run the rectify step, which is to delete the pod and wait for it to be recreated. And then we verify that the rectify step did what we expected to do. And in this case, actually it didn't. The pods came back and they were still not ready. So there is more wrong to these pods than perhaps we can deal with this level 1 issue. And we need to escalate this to level 2. And we then send an email off with the details of this runbook run. So this 5-step process here is useful because it really gives you a lot of hooks to understand how well your runbooks are running, how often they're running, and how often they solve the problem that they think they're going to solve. So typically, as you start your DevOps journey, runbooks will mostly just have this rectify step. And that makes sense, right? You just want to run a runbook that solves the problem, and so you can move on with your day. But eventually, as you mature in your runbooks processes, you'll need to have some understanding of why these kind of runbooks are being run, whether they were successful or not, whether we need to go back and revisit the logic perhaps in the inspect step because the support team is actually running this script a lot, even when the pods are ready. And so that indicates that there's some condition that we're encountering with our applications that we haven't really understood or we haven't really captured in this inspect step. The verify step, again, also captures a lot of that business knowledge that demonstrates that we know that the application is running correctly. And again, if we're running this and the verify step is failing quite often, then we may need to go back and revisit this runbook. So the 5-step process here gives you a lot of hooks to allow you to measure those kind of outcomes and go back and address them. So unfortunately, restarting the backend pods wasn't enough to solve the problem. So now we need to bump this up to level 2 support. And if we look at the runbook that we have to perform this action, we can see that it is, again, a whole collection of CTL scripts. And in this case, we're just collecting as much information as we can to supply level 2 support with the information they'll need to resolve the issue. And getting that information is really half the battle in a support role. Too much is better than not enough. And if you have not enough, for example, it may mean the difference between solving it in a couple of minutes or having to email back and wait a whole day for additional information to come through. So actually what I'll do here is just run this and we'll run through these steps. So these steps are generally quite simple. Here we are describing the individual deployments. So this is for a description of the front end. Then we have a description of the back end. We then get the details of the pods that are created by those deployments. So you can see here we loop over all the individual pods that match a particular name and grab their logs. And so we do that for the front end and back end. We also get a description of the pods, again with this kubectl describe command. And we collect all that information and send it off as an email. So this is where we've represented the creation of a level 2 support ticket.
Hey, Matt, I noticed that in your gathering of the logs, you're setting an output variable, but not only that, it looks like you're creating an array of output variables. Is that what I'm seeing?
Yeah, so what we've created here is, so this commandlet here sets an output variable, so that captures the details of some text in a way that can be consumed in subsequent steps. We've actually used this format here of a variable name and then open brackets, an individual name, in this case the name of the pod, close brackets, and then content. And so that allows us to, when we send an email, to use this looping syntax here. So if we look at this one here, for example, what we do is loop over each of the output variables that have that use that kind of indexed structure, and then we're going to loop over it, place it in a new variable called deployment, and then inside the loop we actually output the content of that variable. And so we've done that quite a few times for all those steps because most of them generate more than one output. There's likely more than one pod for every deployment, for example. And so we use that looping structure here to build up that email.
That's actually really cool. I didn't know you could do that.
Yeah, it's very handy. It's actually a bit of it's quite an advanced feature, but once you know how to use it, it is very useful. So our support ticket has run. I just need to jump into a new browser window here. Actually, sorry, you won't be able to see that. I'll do it here. Okay. Okay, so that Runbook has run, and the end result of that is an email that has been sent with the details of the level 2 support ticket. And that is this email here. And so what we can see is this email is quite detailed. It has a whole lot of details about the deployments, the pods, and the logs. And from this, our level 2 support team can go ahead and resolve the issue. So our problem lies in the backend pods. We know that. What we can see from the logs here is that our pods are reporting this error, unable to bind to the port. And the port is being set to not a number. And so that looks a bit suspicious. So what we might do is go into the details of the deployment. So here we have the backend deployment here that has been described. And we can see in the environment settings that we have this port number, again, set to not a number. And so what this tells me as a someone on the support team is that the deployment is misconfigured. So what I can do is go back to my deployment dashboard here. I'm going to look at the YAML of our deployment. And I can see, yes, the environment has been set to a value that's not a number. It's not correct, so I need to set that to 8080 to match the port that we're exposing. And so what I did there was actually live edited that YAML. So what you can see is that the form here has been updated with that new environment variable. So that's a two-way edit that we do there. So I will save that, create a release, see if that resolves the issue for us.
That was definitely faster than having to go into the containers section and then go into the environment variables of the container and then update it there.
Yeah, you're right. Certainly, if you're familiar with YAML and you're comfortable editing it, that may be your preferred interface on that step. Okay, so here we can look at the verbose logs of our deployment. We will see that that environment variable has been updated. So there's our new environment variable. Deployment has succeeded. We're extracting that IP address of the load balancer. And if we open this up here, so for context, the Kubernetes cluster will be resizing itself to accommodate the new deployment. So we should see this succeed shortly. Okay, there we go. So our deployment went ahead by fixing up that environment variable. We now have the pods have been deployed in their correct ready state. And this is the JSON response from our backend, which is a random quote. So to see how we consume that, we go to the front end. Again, we'll use those shortcut links that we've placed into the task summary. We'll open that up. Here's our random quotes, and we have successfully retrieved our random quote. So that was the deployment of our front end and back end, diagnosed with some support runbooks. So there are a couple of things that I'd like to highlight just in summary for this. The first is that one thing you never saw us do in this demo was run kubectl from the command line. So at no point did I ever have to have kubectl on my local machine. I never had to have any local credentials shared with me. And I never really needed any deep particular knowledge of Kubernetes to run or to support the application that we had been deployed. So the business knowledge that we've embedded into these runbooks as part of these kubectl script steps allowed me to diagnose the issue and gave me the path forward for any issues that were found. And I didn't need to know how to query pod logs, or I didn't need to know that deleting a pod, for example, wasn't destructive, and that's actually equivalent to a restart. It's also worth pointing out that this 5-step process here is something you should look at considering if you're serious about DevOps. The sort of questions that I mentioned earlier, like how successful are the runbooks at solving the problem? Are the inspect or verify steps perhaps capturing the correct state of the cluster? These are all questions that eventually someone's going to ask as you mature that DevOps, as you mature in that DevOps journey. And this process here that kind of surrounds the meat of the runbook, which is the rectify step, gives you the opportunity to extract that information or add the hooks that you need to start answering those sort of queries. So that was the demo. I think we've highlighted everything we wanted to highlight. Sean, should we go to the Q&A?
Yes, I think we should. All right. One of the questions we have, the run books that you used for that support stuff, is that going to be available to someone to take a look at and maybe even copy?
Yes. This hosted instance is open to everyone. So this is webinar.octopus.app. And if you open that in your browser, you'll be given the opportunity to log in as a guest. And the guest has read-only access to the spaces. And from there, you can inspect the runbooks and copy the scripts if that's something you're interested in doing.
All right. Someone asked the edit YAML button. Are you able to put in additional pieces of YAML that may not be represented on the form?
No, that's a good question. So the YAML that's presented in that form is limited to the fields that are exposed by this step. And this step is not comprehensive. Kubernetes deployment resources have hundreds, at least, of individual fields that could be added, and we haven't exposed them all on that step. So let's say, for example, that this was a real property that a Kubernetes resource recognized, but it's not something that we've exposed on the step. So if I try to add it here and click done, that property will actually just be silently ignored and it disappears on the next edit. So we've noted that in the comments up here. And so the way to have any field that's recognized by Kubernetes included in your deployment is to actually copy this YAML and deploy it as part of a deploy raw Kubernetes YAML step. And so this step here accepts any YAML that you want to put in. And this is how you would add fields that are not supported by that opinionated form.
Okay. Another person said when they use the opinionated form, and a deployment fails, like you demonstrated, their actual Octopus deployment fails, how did you get it to succeed even though the pod didn't actually work?
Yes. So that is due to this option here. So what we actually did here to allow this deployment to succeed, even though the pods never entered a ready state, was use the option "Do not wait for the deployment to succeed." If your deployments are failing because the pods are failing, you'll have this option here, which is the default of "Wait for the deployment to succeed." So that's how we worked around it for this demo.
I think we covered this in the demo, but the person is asking Google VMs are able to be used as impersonation for Google activities, right?
Yeah, that's right. So if we go ahead, I'll actually demonstrate it on one of the targets. We looked at it in a step. So this is the admin cluster that we created initially. And so the option that you're referring to there is this one here, to use the service account associated with a VM instead of an account. So what would happen here is I would click yes here, and the worker pool that I run my deployments against would be a worker installed on a VM in the Google Cloud. And so that VM would then have a service account associated with it, and the permissions of the service account is what we would inherit as part of our deployment. Yeah, so this is a really useful way of lifting the need to manage credentials out of Octopus and placing that back into the cloud provider.
This one's about the Terraform step. Uh, Person noticed that when you were setting up the bucket, you had the Google variable, but it looks like you had .account and then a couple of variable filters on those. Can you kind of talk about that a little bit?
Yeah, so this is the runbook, and this is the variables associated with the runbook. And you'll notice here that we have a Google account as a variable. And again, this is one of those new features that came out in 2021.2 without Google support. And so the bit that they're referring to is here. So if I scroll down here, we've had to supply the credentials to this backend block. And so to do that, we've taken the Google a variable and then used one of these expanded properties called JSON key. And this value here is actually base64 encoded, so we need to decode that, which we do with one of these filters here. And then we need to escape that, so any quotes that will appear in the JSON are properly escaped, so they can appear in this string here. So this JSON key is something you can discover actually using a special variable. And so we have it here, Octopus print variables. And so by setting this to true as part of your deployment or as part of your runbook, what you'll see, if I just go back here, the details of all the variables that are available to your scripts are printed in logs. If I expand the verbose logs here, let me just show all these lines. If I do a scan for what we can see here is that the variable that we've added to this project is just shown as the plain variable Google. But then we also have these expanded variables, and this is where JSON key came from. So this is a sensitive variable. The value won't actually appear in the logs, but we know that it is a base64 encoded JSON string, and that's why we've used those filters in the Terraform script to pass the credentials back to the bucket.
Very cool. The next question we have is again on Terraform. Can the Terraform provider by Octopus be used to uh, manage the entire state of the instance itself?
Look, more or less, it is a fairly comprehensive provider. So if we look at the documentation here, you can see the list of resources that are exposed by the provider. And there's a fair amount here, right? It's not, we haven't reached 1.0, so this is not a comprehensive set. So you may find there's actually gaps. And if you do, and you still want to use a provider, please reach out to support and we'll attempt to update the provider to support your particular use case. But yeah, it is a very comprehensive provider at this point, and we do have customers who have quite large Terraform scripts that manage their Octopus instances. So I'd say if that is something that interests you, you should definitely check it out because I think it'll you may find that it will support your use case.
Alrighty. Unfortunately, that's all the time we had for questions. If we didn't get to your specific question, we'll try to go back to those and get back to you. Could you flip back to the yes, the next slide?
Yeah, there we go.
Alrighty. So, just wanted to remind you of the resources available to you. If you needed to contact support, that's support at octopus.com, sales. The advice one is to the solutions team. That's the team that I'm on. So if you have any questions about how do I or what best practices are, that's the one that you would use. We also have a number of resources on YouTube where some of these webinars have been recorded before, and you can go through those as well as some of the Ask Octopus type ones that we have. Thank you very much for joining us today, Matt. It was lovely to have you.
Thank you. It was a good webinar.
I just wanted to let you know we do have the next webinar, which is going to be rollback strategies with Octopus Deploy. And that's going to be with Bob Walker and myself. And again, thank you very much for joining us. And everybody, have a nice day.
Thank you.